The AI world just got a 2.8 trillion parameter, open source giant. It's outperforming closed US models on coding benchmarks, specifically for agents. This changes everything for how we build with AI. Moonshot AI just dropped Kimi K3. This isn't just another model. It's the world's largest open-weight language model ever, clocking in at 2.8 trillion parameters. K3 launched July 16, 2026. Full weights arrive July 27th. It targets long-horizon coding, complex reasoning, and agentic workflows. K3 is truly multimodal, processing text, images, and video natively. This model isn't just big, it's a performance titan. It immediately challenges top proprietary models. Kimi K3 dominated coding benchmarks. It seized the #1 spot on Front-End Code Arena with 1,679 points. It beat Claude Fable 5 and GPT 5.6 Soul in human preference tests. On Program Bench, K3 scored 77.8. This again surpassed GPT 5.6 Soul and Fable 5. It also led SWE Marathon with 42.0. K3 achieved 91.2 on BrowseComp for information seeking. This isn't just incremental improvement. It's a frontier-level open-source model. It's completely reshaping what open-source AI can achieve. What else is under the hood? K3 uses a sparse mixture of experts architecture. It has 896 experts, but only 16 are active per token. This means only 50 billion parameters are active during inference. Moonshot reports a 2.5x scaling IH efficiency gain over Kimi K2. Innovations like Kimi Delta Attention Decode million token contexts up to 6.3 times faster. Attention residuals let layers selectively retrieve representations from earlier layers. Stable latent MOE manages the 896 experts. Quantization uses MXFP4 for weights, MXFP8 for activations. This reduces full model storage to about 1.4 TB. Its API pricing crushes competitors. Kimi K3 costs $3 per million input tokens, $15 per million output. Claude Fable 5 is $10 per million input, $50 per million output. GPT 5.6 Soul is $5 per million input, $30 per million output. This makes K3 significantly more accessible, more cost-effective for developers. This release changes the AI market fundamentally. It closes the performance gap between open and closed models. It forces proprietary providers to rethink their pricing. Developers gain unprecedented access to cutting-edge AI. Self-hosting K3 demands substantial hardware, though. You need at least 1.4 TB of aggregate GPU memory. That means multi-node GPU clusters, a serious hardware commitment. AI agents are a wild frontier. They often deliver chaotic results. Matt Pocock's Mappecock repository is changing the game. Trending on GitHub with over 170,000 stars, this isn't just another prompt hack. It's a collection of 21 opinionated, shell-heavy engineering workflows. They inject rigorous discipline directly into AI-assisted development. These are not a framework. They are small, composable markdown files. Each defines clear instructions, inputs, and expected outputs. They act as precise runbooks for AI agents. The repository came from Pocock's personal .claude directory. It has user-invoked skills, like /grillme, for orchestrating complex flows. It also has model-invoked skills, like /triage, for automated issue management. A crucial /setup Matt Pocock skills configures project specifics. It ensures consistency without hard-coding behaviors. You can install specific skills or the entire catalog via npx skills at latest add Mappecock. They also work as a native Claude Code plugin. Pocock's vision centers on composable practitioner control. He isn't replacing developers. He empowers them. His approach makes AI agents less reckless. It encodes established engineering practices directly into their operational logic. This means shorter, more AI-effective planning sessions, less ambiguity. This isn't just a shift from prompt engineering. It makes AI agents disciplined team members, not just code generators. But even disciplined agents need a guardian. AI agents are running wild in your terminal. They corrupt branches, delete files, and wipe entire repositories. A 2026 DevSecOps survey reported an 84% failure rate. Developers using terminal-based AI agents experienced at least one accidental branch corruption or untracked directory reset. This is a catastrophic failure point. Enter destructive_command_guard. Dicklesworthstone's open-source project provides a crit IH call security layer. It intercepts, blocks dangerous Git and shell commands. It stops AI agents, like Claude Code or GitHub co-pylet CLI, from executing them. Jeffrey Emanuel originally wrote DCG in Python. Darren Gordon ported it to Rust, focusing on raw performance and robustness. It gained serious Commun IHT interest, with over 5,000 GitHub stars. DCG functions as a high-performance safety hook. It analyzes commands using SIMD accelerated pattern matching and lazy compiled regex. It intelligently differentiates a benign grep RM, RF from an actual RM, RF/. This prevents false positives. It's a context-aware guardian, not a simple block list. But how does it achieve this speed and precision? The tool scans deep. It checks here docs, inline scripts, and complex command chains. It finds hidden destructive patterns. Over 50 modular security packs exist. These include core file system, Git, Docker, AWS, and Kubernetes. Crucial protections are zero config out of the box. It offers layered config URA tying for fine-tuning. When DCG blocks a command, it gives clear explanations, safer alternatives, and a JSON denial to the AI agent. It also shows a human-readable warning. It achieves sub-millisecond latency for command classification. It adds just 1.8 milliseconds to overall command execution times. That's imperceptible protection. DCG ensures the terminal doesn't hang, with a strict 200 milliseconds hook deadline. It operates on a fail-open design. Parse errors, timeouts, or unrecognized languages allow commands, prioritizing workflow continuity. This project directly addresses the monumental risks of autonomous agents. It applies the least privileged security principle directly to AI agents. It recognizes their unique operational needs. The future of AI demands not just powerful models, but also structured control and imperative safety. If you found this useful, subscribe for more deep dives like this.